we will be introducing ourselves and all of our group member. First, which is our supervisor, Puan Uzana, binti Ismail, and then me as Nurul Hannan binti Che Harith. I will be presenting the introduction for you guys to understand our project better. So firstly, textile printing can be defined as the process of transferring ink to the textile substrate by using specific printing techniques and machines. The most suitable techniques for textile substrates printing are screen printing, digital inkjet printing, or uses of thermal transfer process. So these three are types of printing techniques that are commonly used in the industry. So, and our project will be focusing on screen printing, which is a process of transferring stencil design onto a surface using a mesh, screen, ink, and a squeegee. So, screen printing is typically thicker than other types of ink, allowing it to adhere well to the various surface and produce vibrant aqueous color. The common ink used includes plastisol ink, water-based ink, and discharge ink. So, all these three types of inks are the type of ink that can be used in the screen printing inks. And for our project, we will be focusing on the water based ink because it is more sustainable compared with the other types of inks. So next, we will be talking about the problem statement and why does this project is needed to make the environmental better place. So first, excessive use of harmful chemicals in artificial fabric dyes like heavy metals, formaldehyd, and other toxic substances in textile industry, and the wastewater that will be produced from it can leave a big negative footprint on the environment. So the second one is artificial ink can be harmful to both workers and consumers' health. It can be exposed to inhalation, in contact ingestion, which can lead to various health issues including skin allergy, respiratory problems, and even certain types of cancer. Okay, so the third one is artificial use of ingredients in making screen printing paste, such as plasticizer that can cause endocrine disruptions. And the fourth one is the fast fashion industry relies heavily on synthetic dyes, resulting in excessive use of chemicals, reagents, and landfill wastewater discarded apparel. So next, moving to the objectives of our project. So firstly, our objective is to produce sustainable printing ink for textiles using biodegradable natural dyes extracted from beetroot, curcumin, and butterfly pea. The second objective is to evaluate the physical properties and its performance of the sustainable printing ink. And the third one is to assess the performance of the sustainable printing ink on various types of fabrics.
Assalamualaikum, my name is Nurul Farhanah and I will be presenting the significance of our project. As we know, the printing ink that we made are derived from natural sources, which is more environmentally friendly. It is biodegradable and can break down more easily in the environment. This can reduce the impact on ecosystem compared to the synthetic ink that took a too long time to break down. By investing in natural inks that might be costly initially, using natural ink can result in cost saving through reduced energy usage, water management, and potential regulatory fines.
Okay, next is materials. There are 4 basic ingredients in the making of water-based ink: water, pigments, plasticizer, and binder. Firstly, of course, water. Unlike solvent-based ink, which use highly volatile organic solvents such as xylene or acetone, water-based ink uses water as the primary solvent. It plays a crucial role in dispersing pigments and binders to create a uniform mixture. Next is pigments. So, pigments are the coloring agent in water-based inks, responsible for providing hue, opacity, and durability. In eco-friendly formulation, natural pigments derived from plants are used to replace synthetic alternatives, thus reducing the environmental impact while maintaining color vibrancy. We decided to make 3 basic colors for this project, which are blue, yellow, and red. Okay, as for blue, we use butterfly pea. Butterfly pea is very common in Southeast Asia. It is known for its very bright blue color. Butterfly pea is very rich in anthocyanin. Anthocyanin is a type of polyphenol compound, making it a natural source of blue pigments. As for yellow, we use curcumin. Curcumin is a bright yellow pigment commonly used as a spice and herbal ingredient. Its strong coloring properties make it useful as a natural dye. And lastly, the pigment red. We use beetroot. It is valued for its eco-friendliness and safety for human consumption. The third ingredient is plasticizer. A plasticizer is an additive used to increase flexibility, softness, and gloss in inks. In traditional formulation, synthetic plasticizers such as PVC-based products are used. However, for our eco-friendly alternative, santan gum is used as a natural plasticizer, making the ink softer and environmentally safer. Santan gum also used as a thickener to thicken the ink because ink for screen printing ink has to be thick so that it can hold the pattern and shapes well onto the fabric. Lastly, for binder, binder is the key component that holds the ink together and ensure adhesion to the substrate. In this project, we use acrylic resin as binder. Binder help form a durable ink layer by binding the pigments and fiber while maintaining flexibility and wash resistance.
The viscosity graph highlights differences in the ink's flow properties, with the standard viscosity set at 20 centipoise for optimal printability. Beetroot ink has a lower viscosity of 15.1 centipoise, which may result in poor coverage or dripping, while curcumin ink is too viscous at 37.6 centipoise, potentially causing clogging or uneven prints. Butterfly pea ink at 19.7 centipoise is close to the standard and requires only minor adjustment. Adjusting the balance of thickeners and solvent can help achieve the ideal viscosity for each ink, improving their overall usability in printing. The surface tension graph reveals that all the inks exceed the standard range of 0.025 to 0.035 Nm, which may hinder their printability and spreading ability on fabric. Beetroot ink has the highest surface tension of 0.2011 Nm, while curcumin and butterfly pea inks have slightly lower values of 0.1192 Nm and 0.1134 Nm respectively. High surface tension can prevent smooth ink application and penetration, leading to uneven prints. To address this, surfactant or wetting agents can be added to reduce surface tension and improve ink performance. The density graph shows that the inks have varying densities depending on the pigment used. Beetroot ink has a density of 1.21 g/cm3, curcumin ink is at 1.06 g/cm3, and butterfly pea ink has the highest density at 2.1 g/cm3. Compared to the standard density of 1.1 g/cm3, beetroot and butterfly pea inks exceed the standard, while curcumin ink fall below it. The higher density of butterfly pea ink may affect its viscosity and flow during the printing process, requiring adjustment in the binder or other additives to ensure consistent application. The light fastness graph reveals that pigment performance differs across fabric types. On cotton, all pigments meet the expected score of 3 or above, with beetroot and butterfly pea performing best. On jute, curcumin ink performs poorly with a score of 1, while beetroot and butterfly pea score slightly better at 2. For wool, all pigments fall below the expected standard, with beetroot and butterfly pea achieving slightly better scores than curcumin. This result suggests that curcumin ink struggles with light fastness, particularly on jute, and may benefit from treatments or fixatives to enhance durability. The white fastness fade graph shows significant variation among pigments and fabrics. On cotton, all pigments perform poorly, scoring 1, while on jute, curcumin ink demonstrates exceptional resistance to fading with a score of 5, outperforming beetroot and butterfly pea inks which score only 1. On wool, curcumin ink perform moderately well, achieving a score of 3 to 4, while beetroot and butterfly pea inks fall below expectation. This indicates that while curcumin ink excels on jute, its performance on other fabrics is inconsistent. Beetroot and butterfly pea inks require improvement in wash resistance, particularly on cotton. The white fastness stain graph evaluates the staining of fabrics after washing based on a grayscale rating from 1 to 5 excellent. The results show that for cotton, all 3 pigments beetroot, curcumin and butterfly pea achieved the maximum score of 5, indicating no staining on adjacent fabric. On jute, beetroot ink maintains excellent performance with a score of 5, while curcumin and butterfly pea ink score 3 to 4, indicating moderate staining. Similarly, for wool, beetroot ink score 5, reflecting excellent stain resistance, while curcumin and butterfly pea ink score 3 to 4, demonstrating moderate levels of staining.
Okay, so lastly, we are going to talk about Sustainable Development Goal. What is Sustainable Development Goal? So basically, Sustainable Development Goal, or commonly known as SDG, are 17 global targets set by the United Nations, or commonly known as UN, in 2015 to address challenges like poverty, inequality, climate changes, and environmental sustainability. They provide a framework for governments, business, and individuals to promote economic growth, social well-being, and environmental protection by 2030. Okay, firstly, SDG 3. Here, SDG 3, which is good health and well-being. It aims to ensure healthy lives and promote well-being for everyone at all ages. By addressing the health concerns associated with harmful chemicals in synthetic dyes, the research promotes safer alternatives, thereby contributing to well-being of workers in the textile industry and consumers. Okay, next is SDG 6, clean water and sanitation. It is about ensuring the availability and sustainable management of water and sanitation for everyone. Because of our product only using natural ingredients, of course it will be biodegradable. Because of this, any wastewater that coming from our product will not be as harmful as the traditional ink. Hence, it will reduce the harmful chemicals in the effluents, which helps in maintaining cleaner water bodies and reducing water pollution. Okay, so SDG 9, Industry and Innovation Infrastructure. This goal focuses on building resilient infrastructure, promoting inclusive and sustainable industrialization, and fostering innovation. This project encourages innovation in the textile industry by introducing sustainable printing techniques and material. By aligning with this SDG, this research not only addresses environmental and health concerns, but also contribute to broader global efforts to achieve sustainable development. The fourth is SDG 12, Responsible Consumption and Production. It emphasizes sustainable management and efficient use of natural resources, reducing waste generation, and promoting sustainable practices. This project supports SDG 12 by exploring eco-friendly alternatives to synthetic dyes. For example, we use pigments extracted from natural ingredients like butterfly pea, beetroot, and curcumin. Other than that, we also use xanthan gum as thickener and plasticizer instead of using PVC-based plasticizer. Okay, because of this, it helps in reducing the environmental impact of textile production and promoting the use of natural biodegradable ingredients. Okay, lastly, climate action. It focuses on taking urgent action to combat climate change and its impact. By developing this sustainable screen printing ink, this research contributes to reducing the carbon footprint and mitigating the adverse effects of industrial pollution on the climate. To conclude, by addressing this SDG, this research not only provides a viable alternative to synthetic inks, but also advances global sustainability efforts, ensuring a cleaner and safer future for both industry and society.